Luke. I was going to introduce now Luke Marsden. You saw him earlier on, but he's now going to talk about his company, HybridCluster. And I'll just load your presentation for you.
Awesome, thanks. Cool, so I guess this is just a sort of 30,000-foot view of some of the features in ZFS that we use. And a little bit about the sort of architecture that we've been working on for some time. Is kind of different to the sort of big shared storage box approach.
The French for view full screen. It's Control
F. French. Cool. Okay. And it works. Good. Cool. Yeah. So I guess just before I dive into how specifically we use the features of ZFS, a little bit on actually what the sort of shape of the architecture that we've been building looks like. As I was saying, it's a little bit different to the sort of approach of a big shared storage box that exports data over NFS or iSCSI. It's more an approach of unifying the compute and the data nodes into the same place. So if these are two nodes in a cluster, for example, then each node has its own built-in storage pool, and then we've got a container-based virtualization layer that sits on top of the storage pool, and we've got a proxy layer that sits on top of that, handling any incoming requests. And this can all run on sort of commodity hardware. It can run on top of cloud infrastructure, and it sort of opens up some interesting possibilities. But so yeah, I mean, the approach is really to having a multi-container system that can be split across multiple nodes running in multiple data centers. And one of the sort of most important use cases that we use, so we lean on features of ZFS for, is effectively backup. And what I mean by that is snapshot, and then I use ZFS destroyed to refer to pruning of snapshots. So what our system does is so just to give a little bit more context first, actually. So each one of these containers that might be running some web application or database, for example, will be backed onto its own independent ZFS file system. And that file system will then be independently snapshotted and replicated out between the different nodes in the cluster. So from a sort of implementing backup perspective, we are using continuous snapshots. So whenever a piece of data changes on a user's file system, we're taking a new snapshot very quickly, and having those snapshots available is a useful way of allowing customers to roll back to previous versions, and sort of that's a typical backup use case. We also prune those snapshots, so we're automatically taking the snapshots and we're automatically deleting old ones. So we keep, for example, the last hour's worth of snapshots down to 30-second resolution. Before that, we keep the last day's worth of snapshots on an hourly resolution, and before that, a daily resolution, and so on. We also do replication across multiple machines, and this is where ZFS send and receive pipelines come in really, really handy. So whenever one of those snapshots gets taken, the system will automatically, it automatically sort of ensures that there are slaves allocated for each container that's in a master mode on a server. And so it will, whenever it takes a snapshot, it will replicate that snapshot to whatever the configured number of other slaves is that could be in the same data center or in a different data center. But Matt's invention of ZFS send and receive is absolutely critical to us being able to do this. And it allows us to do near real-time replication across data centers, and that's really cool. And then the last feature is I sort of already, this is sort of tied into the backup piece, but actually giving users the ability to do a rollback themselves exposes this sort of cool time machine, don't tell Apple I said that feature that lets you, if your website gets hacked, for example, we often deploy this in a sort of web hosting scenario. So if your website gets hacked, then you can roll back to before it got hacked and apply your patches, or if you accidentally drop a table in your database, you can just roll back to sort of 30 seconds before then. And then there's some other sort of neat things that we've built on top of that. The ability, if seeing as this data is being continuously snapshotted, actually just sort of on this replication piece, what I think is really quite neat about the approach of replicating sets of snapshots around between different machines is that rather than a classical backup architecture, which where you're sending your backups off to some backup server, and then if you want to recover your data from that backup server, you have to drag the data back. The architecture that we've got here instead allows every replica to both be a user-facing backup and a hot spare at the same time. And I think that's, I just think that having replicated snapshot trees is really the way forwards for all sorts of use cases. So then, yeah, because we're doing this replication of data around between different nodes, we can also fail over to a very recent backup. So you can specify a threshold to say, if I lose a node, I want to recover to the latest backup within a certain threshold, or that failover can be initiated manually. And we can also, and that's useful, so if a server fails, you can recover all the applications that were on it to another server in the same DC, or if a data center fails, then similarly you can fail over all the applications that were on that server to another data center. Then the live migration is sort of fun, and I'll talk about this in more detail in the other talk I'm doing. But it's basically the ability to, with our proxy layer, seamlessly migrate applications around between different servers and different storage pools and different clouds. So that's it, really. In terms of the platforms that we depend on from an OpenZFS perspective, we've built our platform. The initial version of our product is built on FreeBSD. It's built as a sort of classical web hosting stack, but with some of these neat distributed systems features built in. FreeBSD is an excellent base. It's been very stable, and we've done quite a bit of work to improve ZFS stability on FreeBSD. We're now looking at moving to Linux because of market forces and because of an interest in containerization and porting some of the sort of storage stuff we're doing to that context, and hence the interest now in ZFS on Linux. And we hope to sort of reproduce some of the success we've had making ZFS on FreeBSD more stable with Linux as well. And yeah, so just a general point, I think that OpenZFS has huge potential, especially in the sort of upcoming cloud infrastructure and containerization world. And I'm really excited to see such good forward progress on it. So thanks. Any questions?
Do we have any questions on this side?
Yeah, so what kind of replication latency do you see? Like, what's the lower bound? Like a second, 30 seconds, 2 minutes?
Yeah, it's a great question. I mean, the short answer is it's configurable, and it's a trade-off between like disk I/O and network versus your replication latency. But in typical configurations, we see a replication latency around 30 seconds. And obviously, it depends on your application as to whether that's acceptable for automatic failover or if you just want to do manual failover in that sort of scenario. I have this sort of ongoing curiosity with the concept of doing synchronous ZFS replication, but that's not something we currently have resources to do. Cool. Question over the back. Oh. getting mobbed by
In your
mics.
practical experience, how do application fail over? How do applications behave when you fail over and there are pending connections that will be routed by the proxy? Do they behave well? How about they might have stale data 30 seconds ago, and the connections might be from an already established communication, and on the other side you don't have the data that's been passed.
Yeah, so it's a good question. I mean, so generally, most applications will perform pretty well out of the box. When you take a consistent ZFS snapshot of an application and its file system, well, an application's file system, and then recover it somewhere else, it's just like that server lost power and came back up. So if you've got a decent database, then it will recover automatically pretty quickly. If you're running MyISOM, then maybe you're not in luck, which is why we also have hooks into MySQL in particular to do a flush tables with read lock operation for MyISOM tables. But yeah, the other part of the question was, sorry, what was the other part of the question around?
How do applications behave when, is that really a problem from your experience, or that's something that most of the applications you work with are can live with?
You were asking also about connections and routing as well. And yeah, I mean, so the application behavior is generally fine. Like I say, it's as if it came back after power failure. The question of sort of routing connections around, the approach that we're taking is not to try and get like completely 100% seamless failover. As you can tell, it's more of a sort of people use the word cloudy in a derogatory sense to say things that like aren't like really hardcore up to the millisecond, and that certainly like limits some of the applicability of this approach, but I think that there's still a large class of applications for which it's acceptable. But we'll lose in-flight connections when a server fails, for example, and we'll have a brief period of downtime because there's a timeout before which we initiate a failover. So if someone's doing a long-running download, then they'll have to restart it, or a user might need to reload the page or something.
Then what is the purpose of the proxy? Wouldn't that have been the same situation with normal routing or just rerouting connections?
So one of the nice things about this approach is that it doesn't require any specialist network. You can just run it on a completely commodity network with regular IP addresses. A proxy layer will also publish DNS records, and it'll publish multiple A records for each thing. So you can even have like multiple A records in different data centers. And then if one of the nodes fails and just completely goes offline, then the browser will retry the other IP address. And most well-behaved clients will retry another IP. So in response to like what's the purpose of the proxy, there's also the proxy is also used in live migration, and I'll go over that in the next sort of deep dive.
Okay, thanks.
Cool, no worries. Any other questions? Cool.
Cool. So thanks very much, Luke.
No worries.
I was going to get Matt to then just talk another round of applause.